Hi, this is VA2 AKG or Tango Alpha 1 Uniform Hotel or November Mike 2 Yankee, depending on which country I am. So this is my Heathkit HW 2036A. This is an A. It was later modified to cover the whole 144-148 megahertz. And as you can see, it has a shiny top cover, which is not really a cover. Actually, this was a single-use baking tray from which I made a temporary RF screen. There is the original cover and the rest of the tray. So this RF screen is actually for aligning the receiver with the top cover closed, because the problem I had, I've been repairing this for about 3 months now. It's working fine, but when I did the last alignments and screwed the top cover, I realized that the measurement results were changing with the cover closed or open. So I wanted to properly screen it and do the alignment for FM quieting, which would also mean aligning and improving the sensitivity of the receiver. As you can see, it's even screwed in place with the screws, so it's actually a copy of the original cover. So on top of it, I pasted a layout of the board with holes for the RF coils. For those who might not know, Heathkit, explains in a very detailed way how to align this, even with basic tools, or even by using the S-meter, the microamp meter of the rig itself. But of course, it's best to use if you have a good meter or oscilloscope and other instruments. It's best to use them indeed for fine alignment. So basically what you do is, here you have two coils from the synthesizer, and these two are between the synthesizer and the receiver. Okay, first you get the maximum output from synthesizer, then you transfer it to the receiver board, you adjust it from these two, and in order you go align this 1 2 3 4 and then 5 6 7 8 9 and 10. It's not rocket science. You just need some experience and I'd say some previous experience and knowledge in working with receivers. So if you previously ever built and aligned your own transceiver, it's nothing complicated. So but it takes time, and you do it in many iterations. So today I will see the result of FM quieting, and as you can see, I adjusted my signal generator on -113 dBm, which was the value specified in the specifications by Heathkit. It says 0.5 microvolts will make -15 dBm of FM quieting. So let's test if it does or not. As you can see, we are on external audio output, so we have a dummy load there, and my multimeter is connected to it. And I'll first unsquash the rig. Of course, we won't hear anything, but the multimeter is on dBm position, so I'll bring it to 20 dBm or so, and then I will kick the signal generator here. Let's see how much quieting this will give us. Wow, it's almost -2 dBm or so. So I'm gonna turn off the generator again. See, we have 20, and I turn it on, and we have -2, which means it 22 decibels of FM quieting with 0.5 microvolts, which is far ahead of what Heathkit is originally giving for this rig, which is much better. So what I can do is, just for curiosity, I can go down to -120 or so, and even at -120 we still have 4 dBm, yeah, something maybe a bit more than 4 dBm of FM quieting, which is very good for this rig. Don't forget, this one is almost 50 years old, and it was assembled at home by a gentleman. This was a kit, so it's not a simple rig. It's one with a synthesizer. The cost was maybe $1,000 or so with today's US dollars, but and still it's relatively simple compared to today's rigs, and I think it does a good job. So just to make it a bit, you know, audible, let's do like that. I'm gonna squelch it again, turn the volume down a bit so we won't be disturbed, and put the audio in the internal speaker. So okay, we still have the signal generator on. Okay, let's turn it off. Okay, yeah, that's noise, and now that's quieting. The difference is unbelievable. See, that is FM quieting with some popcorns from time to time, but that's very good. That's very good. We have a very sensitive rig now, a nice radio, which we may proudly use. Okay, thanks for watching. This is VA2 AKG.